So 2.2 is about graphs, and then the first section, so part A, is all about histograms. The first thing, or what a histogram is, you don't need to write all of that. Just pick and choose. Kind of the most important things are that the bars touch each other, whereas we'll learn in a second, a bar chart, the bars don't touch each other. This is for numerical data. So this is a numerical graph. The vertical scale is for frequencies. So you've got frequency on the left side, and then the bottom's going to be whatever your data points are. So uniform, evenly spread, straight across. The next shape is a bell shape, kind of self-explanatory. Looks like a bell.
Isn't that what they use in schools?
Kind of looks also similar to a normal curve. We learned normal has high frequency in the middle and then tails on the sides.
If you bell curve it, does that mean don't colleges sometimes bell curve crazy?
So that the way they do that is the way that they curve the middle or the median of the test scores is going to be the people that scored the average. And most people are going to score within that. Then you've got a few outliers or a few people that scored higher than the average and then lower than the average. But the average is always in the center of a bell curve.
So could it mean your grade goes down?
I've never done a bell curve before, but I don't think that they can go down. I think that they just curve it in a way that everybody goes up, but you may not go up as much as somebody that scored lower.
Like some people, like a person who scored a 90 might get 2 extra points, and then the person who scored a 70 would get 8 to 10.
Yeah. So everybody goes up in some way or stays the same, but the people that did lower usually end up getting more credit than the people that did higher. I don't really believe in that, but that's another topic for another day. Also, there is a skewed. So a right skew means that the tail is on the right. So the tail always follows the skew. And then a left skew means the tail is on the left. So when you're looking at histograms, I could ask you to identify what the shape is, which we'll do an example in a second. The next graph is called a quantile plot, which you'll never ever have to make one of these. You just have to know how to read them. And so a quantile plot, basically reading a quantile plot, if you look at graph A, this would be considered normal because the dots form a linear pattern. They kind of look like they're in a line. More so than B would be not normal because they are more in a curve or not linear. It doesn't matter. They don't need to be curved. They just, if they're not linear, then that means they're not normal. The only thing you would ever have to do on a quiz or a test is just look at the plot and say, is it normal or not? That's the extent that we go in this class. So here's an example of a histogram, and it's an experiment with 2 fair dice thrown 100 times. So the total of all of the bars added up together is 100. That's the total frequency. And the sum of the pips.
It's the
What's
amount
it?
of like the dots that you see on the side.
I've never seen the word pips before. I guess so. I've never seen that word before. The sum was recorded and the following frequency histogram gives the result. So this is a frequency histogram, meaning that the bars are just counted. What was the most frequent outcome of the experiment? 8. So smart. I think this section's pretty easy, just reading the graphs. And how many times did it occur? Is that the next question?
What was the least?
Oh. How many times, just looking at it, did 8 occur? How many times did 8 occur? 20. Okay. The next question says, what was the least frequent? 2. And how many times did that one occur about?
About 3.
Like 2 or 3? I'd probably say 2. I'd say about 2, yeah. Okay, next question. How many 5s, or how many times did we observe a 7? 15? Yeah, it's like right on that line. How many more 5s were observed than 4s? So how many 5s are there?
11.
And then 4s? 7. So 4 more times? Determine the percentage of time a 7 was observed. So we said that, yeah, 15 out of 100. 15%. Y'all are killing it. So good. It will. What is the shape? Bell.
Is it ever gonna be like neither your mom over here?
It'll be one of them. Yeah. Okay, try the next one. Example 3 on your own without my help. Okay, so most frequent is 4. How many weeks were for 2 cars? Sold 9. Determine the percentage, 9 out of 52. And the shape is a right skew because you have some upper outliers. So that makes it a right skew. Outliers are on the right side. All right, this one, it wants us to actually make a histogram. So we're going to do this together. The bottom is going to be, yeah, so I'm going to count up to 10. And I actually need to find the relative frequency before I make my vertical axis to see like what the highest one is. So total frequency out of all of them, if somebody adds those together, let me know what you get. We're in their head.
Can you not use the frequency they give you? Oh.
It wants us to construct a relative frequency.
I got 53.
It does say, I just don't have it in front of me. It's 50 is the frequency? 50. Okay, then I'll take all of these out of 50. And I'm gonna, remember my bars need to touch. So for 1, I'm gonna draw up to 0.32, make a bar. For 2, I'm gonna go to 0.22. 3 is 0.18. It's not very evenly spread, sorry. 4 is 0.14. 0.04. 06. 0. 0.02. 0. 0.02. So it should look something like this.
I got that, that's what I got.
Perfect. So what percentage of the time did she first miss on her 4th free throw? So now I'm just answering what I have on my chart. 0.14, yeah. Or 14%.
Why is 1 at 0.3?
Why is 1 at 0.3? It's at 0.32.
That was definitely relative.
Mine's between the 0.3 and the 0.35.
Oh, okay. I was
What percentage of the time did she make 9 in a row and then miss the 10th one? So basically, which one did she miss the 10th? 0.02 or 2%.
Dang, she getting better.
Then the last question, this is interesting. It says, what percentage of the time did she make at least 5 in a row? So what would I do here? Cumulative. At least 5. So which ones would I add up? 5, 6, 7, 8, 9, 10. Yep. So I need to add all of these.
1, 4, plus 1, right?
Yeah, I can either add the cumulative or I can add just the frequencies. 7 out of 50. Or you can add these up too and get 0.14. Either way you do it, doesn't matter. Add up 5 through 10. Okay. Because that's how many, where she said at least 5. Okay, 2.2b, we're going to kind of fly through because it's just the different types of graphs. And you're not going to really have to make them, but just be able to recognize them. So the first one is talking about a dot plot. I want you to write next to it, parentheses, numerical data. It is. So there's several for numerical. This is another option. For strengths and weaknesses, I would just say, don't even write that on there. Oh, it is? That's nice. So you don't have to write anything?
We have to write the definition.
Ah. I made this like at the beginning of summer, so I don't really remember. Okay.
To write the definition of
It's up to you. Just going to look like this picture. So basically, the data points go at the bottom, and we've made a dot plot before. And then you count up. So the frequency would be, like the first one's 4. The next one is however many. So you're counting up. And these are your frequency. So there's never like a relative frequency dot plot. It's always just frequency. So is everyone good with dot plot? Just looking at, okay, the next one is a stem plot, stem and leaf. This is also for numerical data. So the 3 that we've learned for numerical is histogram, dot plot, stem and leaf. Those all are for numerical, discrete or continuous. Yes.
Is your AP stat class?
Yeah.
Is he the little sophomore?
So the stem is always going to be, there's going to be a key for you, but the stem is usually like the 10s or the 100s or something like that. And then you have the leaves, which are individual data points. So all of these are the data points.
What does it say?
The way that you read the shape, this is kind of interesting. You create, you can read a shape from a stem and leaf plot by just kind of tracing it. But, so this one would be like a bell shape. Kind of imagine like turning it on its side.
That was creepy.
Turning it on its side. That's how you read the shape on a stem and leaf plot. So if it ever asks you for the shape, then it's like turning it on its side. Yeah. A time series graph. This is not, this is for bivariate data, which we haven't really learned yet. I think this section, they just want to talk about all the graphs. Bivariate data. And that's like if you have an X and a Y, like a scatter plot. The only thing that you really need to know from this is just reading the trends of it, and that like the blue, so the blue lines are greater than the red and the green. That's the only thing it would really ask you is like comparing the time series. So if you are in econ right now, they use time series graphs a lot because of reading trends in stocks over time. My dad loves that kind of stuff.
We haven't done it
I want to see what they gave.
Okay, the next one.
Just took different from last year.
The next one is a Pareto chart.
Wait, no, we skipped bar graph.
Oh, I don't think I have it in here. I'm glad you asked that, Hunter. A bar graph doesn't necessarily have any order of how the bars are. Like the highest bar could be in the middle or it could be on the outside or something. In a Pareto chart, it's taking a bar chart and listing it from greatest to least. So the bars are arranged in descending order. There's never a reason why you need to use one over the other, but this whole section is just identifying the graphs. It's never making them. Yeah. You'll never have to make them. You just have to know how to read them. Yeah. Mm.
2 minutes.
Hey, oh. Oh.
Okay, the next one is a pie graph. I feel confident with your pie graph abilities, but this is also for categorical data. So it's split up by percentages. The next one is a frequency polygon, which is kind of weird. This is for numerical data. And the only thing that, like, to read this, it's like imagine that it were just a dot plot going up to all of these points. It's just, it doesn't record the dots in between. It just records the tallest one. But you read it like it's at the frequency. So imagine, like, for the navy line that I just had dots going all the way up. It's like a dot plot without all the dots, just the highest one.
Wait, that's navy. It looks purple.
Makes sense.
Oh. Okay, last thing, and then lunch. So graphs that deceive, 2 things you have to look out for is not starting at 0, a non-zero axis. A graph needs to start at 0. No, you say graphs need to start at 0. Because if you look at the difference between the two, the first one doesn't start at 0, it starts at 10%, so it cuts off all of this area underneath, and it looks like there's a really big difference between the two when it's not as drastic. So if you look at the second one, this one is accurate. This one is not, because it doesn't start at 0. So the last part of notes is these are 2 graphs that are 2 things about a graph that are deceiving or that are not good. The first was that the y-axis does not start at 0. That means that it's deceiving. There isn't as much of a difference between 2 groups as it looks like. The second one is a pictograph. So the way that they have this drawn is that 37% compared to 18% of adults smoke, and it looks like just your eye kind of just is drawn to the picture. Looks like it's, more than double, when in reality it's actually not. So whenever drawings of objects are used to represent the size or the quantity, that's not good. So
It is more than double.
It is more than double.
18 times 2 is 36. But it just, like, comparatively, though, I mean, it just looks a lot bigger. Yeah, it maybe looks triple. So just when you draw pictures of quantities, that's not good. So you don't ever want a picture of a quantity because that can be misleading because your eyes are always drawn towards the picture versus what the numbers tell you in an accurate scale.
So what should we write?
Drawings of objects are misleading.
Done.
And you should have that picture, right?
We finished.
Okay, so let's look at this example. Ah.
That's so easy.
Yeah. What percentage of parents felt the internet was a good thing for their children in 2000 and then in 2006? So I don't know, you don't have the colors, but maybe the shading is different. If you,
Order.
55 first one.
55 and 59.
okay, so in 2000, it was 55%. And then in 2006, it was 59%. Which opinion saw the greatest increase between 04 to 06? So between the second and the third bar, which one had the greatest increase? No effect. No effect either way because it changed by 5%. And it increased. Okay, I want you to try number 6.
Oh, that's not.
Skipping the last.
Do y'all not have this example?
Yes.
Oh, you skipped one? Okay, that's fine.
Let's
Alright.
do 2 questions. Miss McKinley, are we skipping the last 2 questions?
I don't know.
Example 5.
This was my example 6 that I thought you guys had.
No,
Yeah,
no,
that-
example 5, we didn't complete it. Like, there were 2 more questions
Yeah.
on the other one.
Oh, what were the questions? We'll just go back to
Does
it.
a decrease in the percentage of parents who view the internet as a good thing necessarily correspond to an
Oh, I have it. I do have it. What am I thinking? Here it is. I can read it. So does a decrease in percentage of parents who view the internet as a good thing necessarily correspond to an equivalent increase in the percentage who view the internet as a bad thing? What do you think? No, how come?
They could have changed their opinion to no effect.
They could have changed their opinion to no effect. That's a good answer. And when it means like correspond, so if you look at good thing versus bad thing, from good thing from 2000 to 2004, it increases by
If anything, it would be inverse.
12%, and this one just goes down by 1%.
Wouldn't it most likely be inverse?
Right. They could, well, there's a no effect, so there is a portion of people
But, like,
that answer
most
that.
likely it would be inverse if anything.
Yeah, it should be. If it actually corresponded the way that it says it does, if this went up 12%, this should technically have gone down 12%.
It was asking if they both went up. So it like doesn't make sense.
Well, it's talking about a decrease in parents versus the increase.
Oh.
So because like it decreased more on good thing than it increased on bad thing.
Right, and then it goes back up 2%, and here it goes down 8%. So from 2004 to 06, down 8%, but only up 2. So they're not equivalent in their increase and decreases. So no. So why might the percentages within each year not add up to 100%?
Some people
Not
did
everyone.
not answer.
Maybe some people did not answer, so non-response. It doesn't really tell us if they could answer in 2 categories or not. But I don't think they even add up to 100%. They add up to less than 100%. So people that don't respond would be why. Okay, example 6. Try that one on your own. And
76.8%.
76, not 76.8%, it should be 0.768.
8%.
Wait, 0.0768?
Yes, just or just 0.068.
Yeah.
Okay. What about,
Sorry, like,
No, 768.
Yeah, so
0.0768. I'm sorry.
what about the second one? I'm just trusting you guys here. 16.158%.
Why
You can write it either way. You could do 7.68% because it's asking for a percent.
We do 16%.
Yeah. Either way, I will take it as a decimal or a percentage. How many surgeries were not accounted for? How many? 582.
0.6 million.
1,000 or just 582 total? 1,000. So you just take 1.9 million and subtract each
Were we
one.
supposed to do like the actual number?
Mm-hmm.
You could also just have done 1,900 and just.
You could have taken off all the 3 zeros. Okay, last question. So which category tends to have the highest number of hours spent by students and which one has the lowest between exercise and video games? So which category has the highest number of hours spent would be which one? Highest. No, video games. If you look at the graph, there's more in the higher regions. And then the lowest would be exercise. Which category has the most consistency in the data? The ones that are most grouped together. Video games. How come?
One after another, and not a lot of gaps.
Yeah.
That
What
one person
about...
said-
Outliers.
I bet the one person that said 0 for video games is the same person that said 0 for exercise. They just do that.
So I'm just going to ask, this is an extra question, but if I were to identify the shapes of these, what would exercise be? And what would video games be? Yes.